Kollective. Really appreciate you coming in and supporting us. Hopefully, maybe later in the year, we're all able to meet together again. Maybe we can have you present to us in person. But great opportunity, and we're glad to have you here. So thanks for your time.
Oh, for sure. Thank you. I think we visited you guys back in last summer.
I think so. Yeah.
Yeah. All right. Well, hi, I'm Jerry Borger. I'm the product manager for software delivery for Kollective. The product I'm going to talk about, excuse me, is Kollective for ConfigMgr. So I have a few slides and then a quick demo, but I wanted to sort of go over like who we are and answer any questions about our product and take any feedback, and we'll go from there. All right, so who's Kollective? I guess so. Kollective has been around for about 17 years. We have about 5 million endpoints deployed. We used to be based out of Northern California, and then over the last couple of years, relocated our office to Bend, Oregon, which is out in Central Oregon, on the other side of the mountains. And we have some folks in London, India, throughout the world to handle different time zones. So that's most of what Kollective has been doing, since it's been started, has been mainly enterprise video delivery. So that's like webcasting and then integration with other video platforms, and then now Teams and Streams. And we'll talk about that a little bit more, but we use a peer-to-peer protocol for video delivery that we've been using for quite some time. And that's for like on-demand video or live CEO broadcasts in which, thousands and thousands of machines can participate and watch the video, and instead of them all downloading that content individually, that get peered out, or even not even need to have cached like web caching servers, to be able to cache that content. So what they decided to do is, since they've sort of tuned this video protocol, or this protocol to deliver video, they decided to get into the configuration manager market and software delivery market. And that's what I'm going to be focusing on today. So some of our, we have a ton of different customers. A vast majority of these are video customers. Some of them are now software delivery customers, but we've deployed 30,000 machines in some cases, like due to live streams. So our protocol is pretty stable and performs very well over multiple types of networks. So I want to sort of go into, like, we all sort of know what these buzzwords are and such, like what is the modern workplace. And it's like, Windows 10 is not going to be Windows 11 apparently, so it's going to continue to be upgraded. And with that, customers have challenges in managing that content, getting that content out to machines, because the file sizes can be somewhat large, and oftentimes network conditions aren't very useful to getting that content out reliably. So one of our customers had offices in South America in which they had such poor high latency, they were unable to deliver content. They didn't have a DP at the site, and sometimes even if they did have a DP, they would have problems getting that content out there because of dropped packets and such. With our protocols, we've developed it ourselves. It's KDP is what we call it, which is a UDP-based protocol that is very resilient over these poor connections. But we are seeing more and more need for this type of technology to be able to peer out this content efficiently and intelligently without a lot of fuss, to keep machines up to date. So the integration we have is with Microsoft System Center Config Manager. We are looking at Microsoft Intune as well, and to handle co-management scenarios. And this, these solutions sort of fulfill these challenges of handling how do we get stuff out there fast, quickly, without errors, and we don't have to go back and analyze what or redo what we've already done, like redeploy or remediate machines that have failed deployments. So this is sort of more of like a video-centric kind of slide, but the idea is that, whenever you design a network, you're sort of like going for an average, but then you're going to have spikes throughout the, the year, especially with large video deliveries or whatever, or deployments, capacities. Eventually you're going to hit that, and that's going to cause congestion. And what we're trying to do is figure out a way to reduce that so that it's where that congestion doesn't occur, so that you don't have interruptions, especially if you have high profile events and things like that. So our protocol for SCCM, with video, there's like 2 different kinds, which are like high priority, of course, because if you're watching the CEO speak, you don't want any drop packets or any type of buffering to occur. But with ConfigMgr, we use a background delivery, which is more sensitive to the network. So as you can see in the first image here, there's a lot of unused bandwidth, and business traffic throughout the day is going up or down or whatever. Which, then you have background SCCM content that just going to occurs occasionally, but whenever it's occurring, sometimes those hard, even if you set hard limits, you're going to run into issues with congestion. This, at least when I was managing SCCM stuff into corporations, we would have to set deployments to run at certain times. We would be very wary to talk to the network team, and oftentimes they'd run to our desks and say, "Hey, what are you guys doing?" So it was very stressful that we'd have to try to figure out ways to get content out there, do mass deployments where we didn't impact the business. With our product, in our protocol that it's using background traffic. So like we detect automatically, okay, there's saturation, we're going to step down and until and fill up any gaps if they become available. And that just makes it easier to deploy at any time. So our current customers, they used to have to schedule stuff and like pre-stage to distribution points, and now they just basically, once they package it up and it's published in our cloud, they just hit the deploy button any time of day and let it go, and then it just gets there over time. A lot of times faster because it's using, we're not really throttling, so it's using that whatever free bandwidth is available. So this is sort of a simple graph. It's like, okay, so we all know that if you're doing all these different things and you have distribution points that are remote, you're going to have stress on that WAN link. And all we're doing is downloading that content once to a given location and then sharing it out amongst machines. And to get this sort of set up, there's only a few components. There's a server-side component that hooks into ConfigMgr, which I'll get into in more detail in a sec. Then there's firewall ports that we use, depending if you're using a UDP protocol. We can also use TCP if needed. We tend to recommend a UDP, of course. And then you just deploy a client bridge, which is basically the alternate content provider API COM service that we install that is the interaction between the SCCM client and the ConfigMgr client. And then after you decide what you want to publish, or if you want to publish everything to our cloud, you just publish all that automatically and then do your deployments at will. It's pretty easy. Okay, so I wanted to, before I get into like the architecture and such, which might be more technical in nature, does anyone have any questions at this point? Or feel free to just, I'm not sure how you're doing this, Greg, if it's like you're fielding questions or if people are, I'm not watching the chat, so I don't know.
We're pretty easy. If somebody doesn't want to come off mute, I'll relay any questions. So feel free either way. If people want to come off mute and ask, or if you want to throw it in the chat, I'll look for pause and add it then. I don't see anything in the chat right now though, Jerry.
Cool. All right. So here's like a conceptual diagram of sort of how we work, right? So you have your primary site or CAS and on the top here, and then of course your normal workstation. So the way we work is that you install a component which is runs on the SMS provider or site server if you only have one, and that is it monitors what packages or content types that you want published. So it looks at everything, but when you do the installation, you choose, do I want to automatically publish, let's say, applications, packages, software updates, but not OSD content, or just manually publish everything? You have a lot of options on how you want that to occur. Normally, you'd want to set automatic publication so that you do things in SCCM and you don't have to go into our console to publish something. So let's say you did that and you say, we want to automatically publish all packages and applications. When the administrator goes and creates a package, we'll see that, we'll grab the content. or if they make a change to a package that's already been published, we'll go ahead and check the differentials. Or if you delete it from SCCM, we'll go ahead and delete it from ECDN. So we interact with the SQL database that we use to manage all the different content items, files within them, and other settings. And then when you create a package, we go ahead and track that. If it's a lot of little files, we'll go ahead and compress it, and then we'll upload that to our ECDN, which is our grid servers in the cloud that are, for the last 10 years, have been used for video, but now we're storing a lot more content for ConfigMgr. So on the client side, you have your ConfigMgr client, your ConfigMgr cache, and then you install the bridge component. You have the agent, and then there's a cache for the agent. The agent's what's doing all the heavy lifting. The bridge is a very small service that is just mainly interacting with SCCM, which is our ACP. So whenever a policy comes down for the ConfigMgr client, it does a content location request. Once that content location request passes, it then checks to see if there's a locally installed alternate content provider. And once the bridge is installed, we're registered as such, so we'll be invoked at that point. And the content transfer manager at that point sort of steps back and waits for us to do our job. So the bridge will go ahead and work with the agent and to say, hey, okay, I need to get this content ID, package ID dot whatever, or content ID dot what version. And then there'll be some API calls to our grid servers to say, okay, what are our unique identifiers for that? And that's our own identifiers. And then we'll start pulling that content from the cloud or pull it from peers if they're available locally. And then once that's complete, we'll then store it in the collective cache for long-term usage. Typically, you'd want that cache size to be larger to keep that content out there longer, for like if you're doing stage deployments, for example. And then we'll go ahead and either copy it to the ConfigMgr cache, but by default, we'll just hard link it in there. And then once we are done downloading the content, we let the CTM know, hey, we've downloaded it. Here's where you told us to put it in the cache, and then the hash validation occurs on the client side, and then executes whatever you deployed. Does anybody have any questions about the architecture of how the publishing and content go on? If not, I'll just go forward.
We have one question about licensing. I don't know if you want to cover that later, or I can ask it now.
Let's go.
Yeah, how's it licensed? Do you have like multiple features, tiers, or is it one price for everything?
So there's two pieces of it. I'm not a sales guy, so I don't know all the details, but there's of course the video side. So if you're already using us for video, then it's just per device at that point for the ConfigMgr piece. And it's really, there's no charge for like storage. You get like, there might be charge. I think you get like 2 terabytes out of the gate, but there's no egress charges. So if you're downloading gigabytes and gigabytes of data, we're not going to bill you based on that. So it's really just per client. Now you can also just use us for ConfigMgr, which I'm not sure what the ratio is, but the best deal, of course, is if you implement us for video for like Teams and streams, and then want to add on the ConfigMgr, that's usually the less expensive option.
So if you just wanted to do the ConfigMgr side, though, everything you're showing is all one price. There's not different tiers for the ConfigMgr features then, right?
That's correct, yeah.
Okay, all right, thanks.
All right, so since we spoke last year, we've been working on OSD support. So in this recent release, we released about a few weeks ago our implementation of peer-to-peer iPXE. So we're using the iPXE standard. You can flip it back to PXE. We built both in, but by default, you might want to use iPXE because it's using a faster. Instead of doing a TFTP download of the boot image from the PXE service provider, it's using an HTTP send, which is it seems to be a lot faster, of course, right? So that is already, now that we've built this in, any machine, any client can function as a PXE server in effect. And it's not, you don't have to predetermine who's that PXE server. If you enable that feature on, let's say, all your machines on a given subnet, one machine will function as that leader at a given time. And there's an algorithm that it uses to determine who's the leader, and there's some selection criteria that we use. We're building that out even further in the next release. But basically, it tends to be more, servers are going to be chosen, of course, as leaders rather than followers. So that'll handle the Pixie boot if you're at a remote location, doesn't have a local DP, and you don't want to use redirect that traffic to another location, putting in IP helpers or anything like that. For about 6 months now, we've had a WinPE agent. So you inject our agent, which is basically the bridge component, which is the ACP function, and the full agent. We've sort of merged that into one executable that sits in WinPE. So anytime during a task sequence, anytime a content is requested, by adding specific variables in your task sequence, it'll request that content from Kollective, and then we'll either pull it from a peer or pull it from the cloud. And you can disable that cloud download if you want. If you want to only make sure you're pulling from peers, that's an option as well. And then once you're further along in the task sequence and you get the Kollective bridge and agent components installed, then any further content requests will come in through the full client or the full agent. And if you have all this content published, you'll either again pull it from peers or pull it from the cloud. And then we have an analytics platform that we've adapted from the video, which I'll talk about a little bit more, but it will track these deployments that are occurring. And then of course, as the machines are going through their life cycle, they'll just continue to use us for software updates and patches and things like that. So now a lot of people are talking about CMGs now, right? Because everybody's at home. So we work very similar in this scenario. As long as the content location request, like if a machine out there at home, if that content location request and that policy can come down through the CMG, it will invoke the ACP and then pull from it'll kick off our Kollective agent. And then you won't need to download that content from a cloud DP. It would just use Kollective for that. And that might be useful if you're concerned about egress charges or anything like that. So that, because it's all built into our licensing so that, depending on if you're deploying like large applications to these users, you'll pull from their, hopefully if you're using split tunneling, if they are on VPN, they'll just pull directly from our cloud as opposed to going through a proxy or whatever. Now, the peering, of course, probably is not going to be that great because they're probably at home by themselves, but they would get some benefits in the sense of reducing any type of impact to their home, their Netflix, whether they're watching on Netflix at that time. Because that same protocol where we're very sensitive to network congestion is being used, is in this scenario as well. So I want to talk about our just sort of our peering mechanisms. Like one of the things that when I started working at Kollective is that I was very surprised that they figured out how to do peering and network mapping without having to define the network. So in essence, if you implement this type of product, you by default can just get rid of your boundary groups and such. But a lot of other products or other solutions, you have to define the network, right? You have to say, this is my subnet. I'm going to group these two subnets together, and this is my peering group. We don't require any of that. It's dynamic in nature, and you could just basically deploy us, delete your boundaries and boundary groups, create just one for all your location requests to pass, and then allow us to determine what's the best peers. So we have directory servers and such in the cloud that we're using to track which machines are good peers, where the content is. We do a directory when a machine requests content. It's going to look at this local subnet, of course, first, and then there are predefined boundaries if you want. You can set locality, what we call localities. Mainly customers use that for like VPN scenarios where they don't ever want to peer. So they'll create a VPN locality and just say no peering here. Normally you're not going to have that problem though, because two VPN clients typically can't communicate with one another. So then we look at things like what's the external IP address, the ICMP trace routes to peers. Like let's say a machine did have content in cache and then he's offline. that test, we won't waste a lot of time looking for that. We'll just try to do a detection, and then we'll go into the LAN and say, okay, well, we have metrics that you can say, well, 2 hops or 8 milliseconds, and you can define these. There's a gazillion different settings to sort of refine this for your network. But then we'll just go to the LAN and eventually go to the WAN and look for content there. And if we find that it's faster to go to the cloud, we'll just break out and go to the cloud and pull that content from there. So we're using this intelligence to sort of find content the fastest way to get the content for each individual system at the time that that request comes in, rather than predefining that based on whatever your network looks like. So our analytics pack platform, this has been modified for ConfigMgr, but we're tracking things like how many files are in packages, how many deliveries occurred, how many agents were involved, and then of course how many megs or gigs are saved. Because again, like if you have 100 machines requesting content at the same time at a given location, it's only going to get delivered once over the WAN, and that data is sent back to our analytics platform, which can be tweaked, and these are multiple dashboards that if you're good with this sort of big data, and you can create kind of all kinds of dashboards for yourself. We also track peering efficiency because that's important for us to have a high peering efficiency. And then of course bandwidth savings per package. And then we have like geolocation maps built in that this might not be useful if you're not global, but you can sort of see where that for that given package, all the different locations that are involved in that deployment. Other stats are things like delivery status, what's in progress failed, and then we have some tracking over time to see what you can sort of see what the velocity is of a given delivery. And then if you do define your networks, you can certainly tag network information in our system with friendly names. That then you can go ahead and you'll be able to see what the top localities for peering and your deployments are occurring. And then of course we have external IPs that if you are looking at it from that point, you can. And then we have like tracking of WAN, LAN, and just what is origin. Origin means that it pulled from our cloud. There's also we have a lot of folks that are data scientists that work for us that are developing tools, but this is a peering graph that is built into our reporting that you can sort of do it. You can say, all right, I want to check this deployment, and then see visually the peering graph for that deployment. So you can see here, and this is dynamic. This is a screenshot, but this is dynamic in nature if you're using it. So you can actually select different nodes here. Each blue node actually did the download from another peer, and the green node is basically the machine that pulled from origin and now is peering that out. This is somewhat useful in the sense that you can sort of see how your networks be functioning, because if you have some machines that are sort of all breaking out to the internet and are not communicating with peers, you could say, well, maybe there's something wrong with this network. And then you can get some more details by selecting each individual node, and you can move this stuff around. It's visual. The visualizations allow you to zoom in and expand and sort of dig in a little bit if needed. So yeah, so these are sort of all the different products that we integrate with to some extent. There are a bunch of video platforms that we've had integrations with for some time. A lot of the focus lately has been with Microsoft's stack and things like Stream and Skype meeting broadcasts and Teams meetings. If our agent is installed, we'll be able to, and multiple people are participating in a particular video stream, they'll all start peering that content as opposed to individually downloading it. And then, of course, our integration with SCCM is already there. We're looking at Intune and then other use cases for this platform.
Jerry, we did get a question. If you can provide a little information on how you're different than maybe your competitors or even Pure Cache and DO. So I don't know if you have something you can give some detail on that.
Sure. Yeah. So with Pure Cache, I haven't followed it that closely in the last 6 months or so, but I think there's still dependency on boundary groups and defining your boundaries. I do believe that you can now download different parts of a file over Pure Cache. I'm not entirely sure. I can only say that the major difference is that we don't require any type of network definition or mapping. I know that some of customers that they did look at combining solutions like Pure Cache and Branch Cache and using DO in some scenarios. And trying to get by with just sort of putting all these technologies together. I guess the big differentiator probably is that we're sort of an automatic platform. You just deploy it and allow us to do all the metrics, and you don't have to really manage it after that.
Okay, thanks.
Mm-hmm. Now, I won't really go into what our competitors. I think that a lot of our competitors are moving to Intune, or they have had Pixie service capabilities for some time. You know, we've only been doing this for about three years now, so we're still trying to fill in those gaps at this point, which I think Intune's what we hear about the most of what a lot of folks are looking at. That's pretty much it for the slide deck. Does anyone have any further questions on it? How am I doing on time? Let me check.
Yeah, you're doing well. We got like 20, 25 minutes.
Okay. Well, I can do like a quick demo then.
Okay.
Let me share my desktop. Where is it? Share remote desktop manager. Okay, so on what I have here is like a small lab that's and it's on VMware internally. Hopefully it works well. I'm on VPN right now. So this is our console. The publisher service is installed. SCCM is installed. It's a single primary site, and essentially, you know, the console is pretty lightweight. This is the default view where it basically goes into all the content items. Oh, sorry about that. All the content items that you have and their current status. So we'll track publication status and what content type it is. You can do filters and searches. Most likely, you're not going to be in here a ton, because if you automatically publish content, it just you don't really need to validate it after you've been using the product for a while. You should be comfortable that it's working as expected. And then you can do some things here, like you can select a content item and you can synchronize it. Let's say you think, oh, well, maybe I want to make sure that everything's right, that all the files in my package source is the same as what's in the ECDN. You can say we don't want to publish this anymore, which will delete it. You can disable fallback to distribution points if you want, or allow that. So we have a feature that if, let's say, you never want a particular package, if for some reason we can't get it to fail back to a DP because you don't have one locally anymore, you can set that as a policy on that individual content item if you want. And then change publication modes and fallback modes for multiple items at once or whatever. This is pretty simple interface. We're tracking just all the different content items and their status pretty much. And this is really just a visual validation that, yep, when it says it's published, I know that I can do my deployment at that point. And for client side management, there's we track all the different machines that are registered and that are communicating with the publisher and the content manager component, and then which machine is functioning as the leader at a given time. So if I were to restart services on this top box, which is the CAS, an election will occur and another machine will become the leader, and then you can see who the leader is. The reason this is useful is if you're doing like Pixie at a remote location and someone's out there and they say, hey, I can't Pixie boot, you sort of need to know where to get log files or what to check or who the particular leader is at a given time. So that's what this has been. This is developed for. And then of course there's like settings that you can define policies for. Okay, all right, I want to automatically publish packages, but maybe you don't want to do it for task sequences or software updates. And then settings to communicate to our DMS. Like this is like information of this is your company name, for example, and then what our DMS is like an identifier. That's on the internet. And there's some configuration settings here. A lot of settings are in the database that we're exposing more in the UI. And then we have some reporting stuff that you can just sort of get a general overview and then double click, and then it'll filter into, like, let's say you had errors, you would double click, it'll add a filter here and just show you all the errors, and you can handle that. So what I wanted to do is, am I still on?
You're still here.
Okay, I lost connection to this VM. Let's see. Come on, demo gods. Okay, so what I'm looking at here is 2 machines on the same subnet. And this page here is actually just a local browser that's connecting to shore.contigi.com, which it translates to, it's basically a loop back to its own agent. So it's connecting to its own agent, and it's going to show you, I'll show you what it's going to do is, like, you'll see when I do a deployment or execute a package, the actual peering that's occurring. And if your user knows how to get into this, they can certainly see this. But it just gives you a visual way to see or make sure that things are working. And then also there's like inbox tool, like what's in the cache, other kind of tools to send agent stuff, and then agent validation checks. So let's do a test. I did this one earlier, so I think it should work. I have a deployment for this office. I think it's like 250 megs or something. And then same thing on this other machine, and none of these machines have it. Did I switch? Oh, it might be slow. Looks like I lost some connection to this guy. Anyways, I'll kick off the deployment on the first guy, and hopefully the other machine will come up. So I'll go ahead and do deployment. Should be invoking us at this point. And then now you can see on this machine that it is starting to track the download. And based on the color schemes, you can see, all right, this pulling from origin, because I've made sure that none of the machines had this package in cache. My idea was that I would actually show you the other system, but that is not. Let me reconnect to it. All right, cool. So this is the other guy. I'm going to go ahead and hit install here, and then it should start downloading, and I should start seeing it serving content. So this purple graph is actually showing you serving. So now this parts of this file or chunk of files is actually being served to the other system, and part of it is actually being downloaded from the ECDN. And then on this machine, what I should be seeing is, yep, so it is pulling content from a peer and not from the ECDN, and actually serving some other chunks of that file to the other machine. So we can dynamically break apart all these chunks of data, and which machine doesn't have a piece of it, we'll start sharing those as a mesh format to all the different systems. And this can be scaled pretty large, like hundreds of systems. Some of our video streaming, like I think our largest event was like 35,000 users at one time. So it's very resilient protocol that will work in the background, at least from ConfigMgr perspective. And this is just tracking the different, like the URNs and such that it's doing. So this should complete the download eventually. But this is just sort of a sample of how it works, where you don't really have to define who is going to be the master or who's going to hold a master copy. You don't have to worry about distribution points. In effect, just allow us to do the pairing for you, and we'll make sure it's as efficient as possible, and then report that metric to you in our analytics package. That's all I had, I think.
Drew, do you have
fast?
do you have let's see, do you have any type of like a pre-cache or pre-stage ability for things like OSD to make sure that the content is there when the first client needs it, or how do you work with OSD?
So with pre-staging OSD content is we're working on that right now, as we now have like a console and a UI and such that you can actually define you can actually see what collections or machines are in. Right now, if you wanted to do so, you basically would have to make a copy of your task sequence and then deploy it to a given location without actually executing it. And it'll preload everything at that point, and not execute it. But the problem with that is that you have to have multiple copies of the task sequence because you don't want to execute it, right? So you'd have to put in a step to terminate the task sequence, and then change the deployment to say download everything before actually starting to deploy, run the task sequence. One of our goals was to make sure that we had a Pixie support. The next thing, parallel, we're looking at Intune and pre-positioning, where you'll be able to go into the console and say, this task sequence or XYZ pieces of content, I want to target to a given collection, in which at that point, those machines and within that collection will then, outside of SCCM, download that content.
Okay, great. Let's see, any other questions or feedback?
Yeah, if you guys think of any feedback, things that you'd like to see in a tool like this, or please let me know, because we are actively developing this still, of course, right? So I'm curious to know what is hot top. I know everybody's working from home right now, so a lot of this pairing stuff is just sort of moot. Hopefully we all eventually go back to the office to be able to, which I assume you're going to have to some extent, in which this would become a little bit more sort of useful in the scenario. But it's like we're all at home and everybody's sort of living in their own island, using their own internet, which, I guess sort of relieves these WAN issues. But there are issues with like VPN concentrators and being able to connect to work resources that we still might be able to assist with. But yeah, any feedback would be great. Thank you.
All right. Thanks for your time, Jerry. Really appreciate it.